Okay, today we are going to talk about the physical properties of halogens, and you should be able to, at the end of the lesson, you should be able to explain the trends in physical properties of halogens by using the concept of intermolecular forces. In short, what do we have here? We have a periodic table. Okay, we have some notes to write, and then a picture, and a video to watch. Okay, and homework to do. Okay, let's start with the refresh our knowledge of halogens. Okay, remember they are present in the 7A or 17 groups of what periodic table. Fluorine, chlorine, bromine, and they are members, and then they are non-metals. They are diatomics in nature. Okay, and fluorine is yellow, chlorine is greenish yellow, and then this one is reddish, more reddish, and the other one is more purple. Why is this solid? You know, iodine. This is bromine. This is chlorine. Fluorine is not in this picture. And then, if you check the physical state, fluorine, chlorine, bromine, iodine, astatine, fluorine, chlorine, they are gases. Bromine is liquid. Iodine is solid. What is the trend here? Trend. I mean, like, if you go down the group, it goes from gas to what? Solid. Okay. And then if you check multiple and boiling point increase down the group, and volatility, if you down the group, it decreases, and you can include density will increase down the group. Okay, like this. And you should be able to explain these trends by using the concept of what intermolecular forces. Um, but before, uh, should we should find the trend in van der Waals forces. Okay, what happens? You go down the group, the strength of van der Waals forces increases. Why? I'm going to explain now. Okay, see, fluorine. If you check your table, fluorine has. Okay, sorry. Fluorine has 9 protons. Neutral for me has 9 electrons. Okay, so but fluorine is diatomic. I told you is going to be 9 times 2. It has 18 electrons moving in the molecule. Okay, one fluorine molecule has 18 electrons. You should be able to find them. Okay, and then if you do the same thing with the chlorine, chlorine is going to be 17. Okay, and then one atom of chlorine has 17 electrons. So chlorine molecule is diatomic, is going to be what? There are 2 atoms inside, so it's going to be 2 times 17, so it's going to be 34 electrons. Okay, and then if you check B bromine, okay, it's bromine. Okay, that one is going to be 35. Bromine is 35. I got these numbers from what? From periodic table. 35 electrons. Okay, and then Br2 as what? Okay, it's going to be 70 electrons. Yes, 70 electrons. 35 times 2 because it is diatomic. Okay, there. And then do the same thing with the iodine. Okay, iodine. Sorry for that. Ion. I is a symbol of iodine. Okay, it's 53. Okay, 53 there. So because in one I2 is going to be 53 times 2. So it's going to be 106 electrons. So let's rewrite them. Okay, if you write I2. Okay, then what's coming? Br2. Okay, then Cl2, then F2. Okay, in one I2 molecule you have 106 electrons. In one Br2 molecule you have 70 electrons. In one Cl you are going to be, you will have how many electrons? Is 34 electrons. Okay, and then in one F2 you have 18 electrons there. So it says what? It says iodine has the greatest number of electrons. So what is the relationship between the strength of van der Waals forces and the number of electrons? You know, because they are number, they have van der Waals forces. The relationship is direct. I mean, the greater the number of electrons, the stronger the van der Waals forces. Okay, the greatest the number of electrons, stronger the number of stronger the van der Waals forces. So iodine has the strongest van der Waals force, or has the greatest number of van der Waals forces here, than bromine, chlorine, fluorine, orca. Then trends in physical properties they are all related to the strength of van der Waals forces. Let's see. Okay. Okay, let's see. Okay. I mean, if you check multiply and boiling point, it increases down the group. And the same with what? Same with the van der Waals forces. It multiply and boiling point increase down the group. The strength of van der Waals forces increase down the group. Okay. And the physical state, gas, liquid, solid, and if solids have stronger intermolecular forces, remember, you can generalize like that. Okay. And the one left there, it is volatility. What's it? It's a property of matter. Okay, it describes how easily, how readily a substance can vaporize. Okay, can vaporize, turn into gas. Okay, so it is inversely proportional to the strength of van der Waals forces. You can compare the volatility of bromine and iodine. They check bromine is more volatile than iodine, okay, because it has a weaker van der Waals forces. Okay, the only property is inversely proportional to the inversely related to what? Related to the strength of van der Waals forces. Okay, overall it's like this. Yeah, you should be able to use the number of electrons to find the trend in the strength of van der Waals forces for all, and then compare the physical properties with what? With this concept. Okay, that's it. That's it. You have a video to watch, and then to refresh your knowledge of halogens, and then homework to do. See you.